Grade 9 Work and Energy Part 1 NCERT Textbook Questions and Answers. Page number 148. Question number 1. A force of 7 Newton acts on an object. The displacement is, say, 8 meter in the direction of the force. Let us take it that the force acts on the object through the displacement. What is the work done in this case? Answer: force F equals 7 Newton, displacement S equals 8 meter, work done W equals force F into displacement S. Therefore, W equals 7 into 8, 56 Newton meter or 56 Joule. Page number 149. Question number 1. When do we say that work is done? Answer: work is said to be done by a force acting on an object causes some displacement of the object along the direction of the applied force. Page number 149. Question number 2. Write an expression for the work done when a force is acting on an object in the direction of its displacement. Answer: expression for the work done is given by work done W equals force F into displacement S. W equals Fs. Page number 149. Question number 3. Define 1 joule of work. Answer: 1 joule of work is defined as the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of the force. Page number 149. Question number 4. A pair of bullocks exerts a force of 140 Newton on a plough. The field being ploughed is 15 meter long. How much work is done in ploughing the length of the field? Answer: force F equals 140 Newton, displacement S equals 15 meter, work done W equals force F into displacement S equals, therefore W equals 140 into 15 equals 2100 Newton meter or 2100 Joule. Page number 152. Question number 1. What is the kinetic energy of an object? Answer: kinetic energy of an object is defined as the energy possessed by a body by the virtue of its motion. Every moving object possesses kinetic energy. Page number 152. Question number 2. Write an expression for the kinetic energy of an object. Answer: the expression for the kinetic energy of an object is given by Ke equals half mv squared, where Ke equals kinetic energy, m equals mass of the body, v equals velocity of the body. Page number 151. Question number 3. The kinetic energy of an object of mass m moving with a velocity of 5 meter per second is 25 joule. What will be its kinetic energy when its velocity is doubled? What will be its kinetic energy when its velocity is increased 3 times? Answer: mass equals m, velocity v equals 5 meter per second, kinetic energy Ke equals 25 joule, Ke equals half mv squared, 25 equals half into m into 5 squared, so m equals 2 into 25 divided by 5 squared equals 2 kilogram. When velocity is doubled, v equals 10 meter per second. Then we have kinetic energy Ke equals half mv squared, Ke equals half into 2 into 10 squared equals 100 joule. When velocity is tripled, v equals 15 meter per second. Kinetic energy Ke equals half mv squared equals half into 2 into 15 squared equals 225 joule. Page number 156. Question number 1. What is power? Answer: power is defined as the rate of doing work. If the work done by an object in time t is W, then power P equals W by time. Its unit is joule per second or watt. Page number 156. Question number 2. Define 1 watt of power. Answer: when a work of 1 joule is done in 1 second, the power is said to be 1 watt. 1 watt equals 1 joule per second. Page number 156. Question number 3. A lamp consumes 1000 joule of electrical energy in 10 seconds. What is its power? Answer: energy, that is work done, equals 1000 joule, time t equals 10 second, power of lamp P equals work done by time equals 1000 by 10 equals 100 watt. Page number 156. Question number 4. Define average power. Answer: average power is defined as the ratio of total work done to the total time taken. Page number 158. Question number 1. Look at the activities listed below. Reason out whether or not work is done in the light of your understanding of the term work. 1. Suma is swimming in a pond. 2. A donkey is carrying a load on its back. 3. A windmill is lifting water from a well. 4. A green plant is carrying out photosynthesis. Answer: 1. Work is done by Suma because she displaces the water by applying the force. 2. Donkey is not doing any work as the weight he is carrying and displacement are perpendicular to each other. Then no work is done. 3. A windmill works against the gravitational force to lift water. Hence, work is done by the windmill in lifting water from the well. 4. No work is done because there is no force and displacement are present here. Page number 158, question number 1. Look at the activities listed below. Reason out whether or not work is done in the light of your understanding of the term work. 5. An engine is pulling a train. 6. Food grains are getting dried in the sun. 7. A sailboat is moving due to wind energy. Answer 5. The engine applies a pulling force on the train and the train moves in the direction of this force. Therefore, engine is doing work. 6. No work is done during drying your food grains because there is no force and no displacement. 7. Work is done by the wind as it moves the sailboat towards the direction of the force exerted by the wind. Page number 158, question number 2. An object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. The initial and final positions of the path of the object lie on the same horizontal line. What is the work done by the force of gravity on the object? Answer. When the object moves upwards, the work done by gravity is negative, and when the object comes downwards, there is a positive work done. So, the total work done is 0 in throughout the motion. Page number 158, question number 3. A battery lights a bulb. Describe the energy changes involved in the process. Answer. A battery converts chemical energy into electrical energy. In an electrical bulb, the electrical energy is first converted into heat energy. This heat energy causes the filament of bulb to become white, hot, and produce light energy. So the energy changes involved when a battery lights up a bulb are chemical energy to electrical energy to heat energy to light energy. Page number 157, question number 4. Certain force acting on a 20 kg mass changes its velocity from 5 meter per second to 2 meter per second. Calculate the work done by the force. Answer. Mass of the body m equals 20 kg. Initial velocity u equals 5 meter per second. Final velocity v equals 2 meter per second. Therefore, work done by the force equals change in kinetic energy equals half mv squared minus half mu squared equals half m into v squared minus u squared equals half into 20 into 2 squared minus 5 squared equals 10 into 4 minus 25 equals 10 into minus 21 equals minus 210 Joule. Page number 157, question number 5. A mass of 10 kg is at a point A on a table. it is moved to a point B. If the line joining A and B is horizontal, what is the work done on the object by the gravitational force? Explain your answer. Answer: work done by gravity depends only on vertical displacement of the body. It does not depend upon the path of the body. Therefore, work done by gravity is given by the expression W equals mgh, where vertical displacement h equals 0. So, W equals 10 into 9.8 into 0 equals 0. Hence, the work done on the object by the gravitational force is 0. Page number 157, question number 5. The potential energy of a freely falling body decreases progressively. Does this violate the law of conservation of energy? Why? Answer: the potential energy of freely falling object decreases and its kinetic energy increases progressively. So, in this way, the total mechanical energy, that is kinetic energy plus potential energy, remains constant. Thus, the law of conservation of energy is not violated. Page number 158, question number 7. What are the various energy transformations that occur when you are riding a bicycle? Answer: while riding a bicycle, the muscular energy of the cyclist is converted into kinetic energy rotational of the pedals of the bicycle, which is transferred to its wheels. The kinetic energy of the rotation of the wheels is converted into kinetic energy of the bicycle and the cyclist. Page number 158, question number 8. Does the transfer of energy take place when you push a huge rock with all your might and fail to move it? Where is the energy you spend going? Answer: yes, the transfer of energy takes place when you applied energy, but there is no work done as the displacement is 0. The energy you spend goes to the rock and the ground. Page number 158, question number 9. A certain household has consumed 250 units of energy during a month. How much energy is this in joules? Answer: 1 unit equals 1 kilowatt hour equals 3.6 into 10 raised to 6 joule. So 250 units equals 250 kilowatt hour equals 250 into 3.6 into 10 raised to 6 equals 9 into 10 raised to 8 joules. Page number 158, question number 10. An object of mass 40 kg is raised to a height of 5 meter above the ground. What is its potential energy? If the object is allowed to fall, find its kinetic energy when it is halfway down. Answer: mass m equals 40 kg, g equals 9.8 meter per second squared, h equals 5 meter. So the potential energy equals mgh, 40 into 9.8 into 5 equals 1960 Joule. At a height of 5 meter, object has a potential energy of 1960 Joule. When this object is allowed to fall and it is halfway down, its height above the ground will be half of 5 meter. 5 by 2 equals 2.5 meter. So the potential energy equals mgh equals 40 into 9.8 into 2.5 into 5 equals 980 Joule. Page number 158, question number 11. What is the work done by the force of gravity on a satellite moving round the earth? Justify your answer. Answer: when a satellite moves around the earth, the work done by the gravitational force is 0. This is because the satellite is moving in a circular orbit. Thus, the direction of displacement of the satellite is perpendicular to the force of gravity. Hence, work done is 0. Page number 158, question number 12. Can there be displacement of an object in the absence of a force acting on it? Think, discuss this question with your friends and teachers. Answer: if an object is in a state of motion, then as per Newton's first law of motion, in the absence of any external force acting on it, the object will maintain its motion along straight line. So, the object will have displacement. However, if the object is initially at rest, then there can be no displacement. The work done by the person is 0. Page number 159, question number 13. A person holds a bundle of hay over his head for 30 minutes and gets tired. Has he done some work or not? Justify your answer. Answer: the person does not do work because no displacement takes place in the direction of applied force, as the force acts in the vertically upward direction. Due to upholding the weight against gravity, let the man get tired. Page number 159, question number 14. An electric heater is rated 1500 watt. How much energy does it use in 10 hours? Answer: power P equals 1500 watt equals 1.5 kilowatt. Time taken T equals 10 hours. Energy equals power into time equals 1.5 into 10 equals 15 kilowatt hour equals 15 units. The energy consumed by the heater is 15 units. Page number 159, question number 15. Illustrate the law of conservation of energy by discussing the energy changes which occur when we draw a pendulum bob to one side and allow it to oscillate. Why does the bob eventually come to rest? What happened to its energy eventually? Is it a violation of the law of conservation of energy? Answer: law of conservation of energy states that energy can neither be created nor be destroyed. It can only be converted into one form to another form. Now, let us consider a pendulum in which to and fro motion will take place. When pendulum bob moves from its rest position, that means mean position, to another extreme position, its kinetic energy will be converted into potential energy when it is raised at some height h. Now, when it comes back to its mean position, then its potential energy will be converted into kinetic energy, and this phenomenon will take place again and again. The bob will eventually come to rest due to the frictional resistance offered by the air on the surface of bob, and pendulum loses its kinetic energy to overcome this friction and finally comes to rest. The law of conservation of energy is not violated because the kinetic energy loss by pendulum to overcome the friction is gained by surrounding. So, total energy of the system will remain conserved. Page number 159, question number 16. An object of mass m is moving with a constant velocity v. How much work should be done on an object in order to bring the object to rest? Answer: mass of the object equals m, initial velocity equals v, final velocity equals 0. Work done on an object W equals change in kinetic energy. W equals half mv squared minus 0 equals half mv squared. Hence, the work that should be done on the object in order to bring the object to rest is half mv squared. Page number 159, question number 17. Calculate the work required to be done to stop a car of 1500 kg moving at a velocity of 60 km per hour. Answer: mass of the car m equals 1500 kg, velocity of the car v equals 60 km per hour equals 60 into 5 by 18 equals 50 by 3 meter per second. The car is in the motion, so its energy equals kinetic energy equals half mv squared. Ke equals half into 1500 into 50 by 3 the whole squared equals half into 1500 into 50 into 50 by 9 equals 625,000 divided by 3 equals 208 333.3 Joule. Hence, the work required to be done to stop a car is 208 333.3 Joule. Page number 159, question number 18. In each of the following, a force F is acting on an object of mass m. The direction of displacement is from west to east, shown by the longer arrow. Observe the diagrams carefully and state whether the work done by the force is negative, positive or 0. Answer: in the first case, the force and displacement are perpendicular to each other, so work done is 0. In the second case, the force and displacement are in the same direction, so the work done is positive. In the third case, the force and displacement are in the opposite direction, so the work done is negative. Page number 159, question number 19. Sony says that the acceleration in an object could be zero even when several forces are acting on it. Do you agree with her? Why? Yes, Sony is right, because acceleration in an object could be zero even when several forces are acting on it if the resultant force F is 0. From Newton's second law, F equals ma. If the net force is 0, F equals 0, then ma equals 0, or acceleration A equals 0. Page number 159, question number 20. Find the energy in kilowatt hour consumed in 10 hours by 4 devices of power 500 watt each. Answer: power equals 500 watt. Power of 4 devices equals 4 into 500 equals 2000 watt. Time taken equals 10 hours. Energy consumed equals power into time equals 2000 into 10 equals 20,000 watt equals 20 kilowatt hour. Page 159, question number 21. A freely falling object eventually stops on reaching the ground. What happens to its kinetic energy? Answer: when an object falls freely towards the ground, its potential energy gets converted into kinetic energy. As the object hits the hard ground, all its kinetic energy gets converted into heat energy and sound energy. It can also deform the ground depending upon the nature of the ground and the amount of kinetic energy possessed by the object.